Today we start with lecture 17 of MET 303. We start with fx equal to mod x. This is even function. Is an even function. You are very well aware that f of minus x equal to fx, then we call such a function as even function. And obviously here mod of minus x equal to mod x, and though mod x is even function. Here we proceed to find Fourier series expansion of fx equal to mod x. For that, we start with a0 equal to 1 upon 2 minus pi to pi mod x dx. This is equal to 1 upon 2 0 to pi x dx. So this is equal to 1 upon pi. This is 2 times, right? So this is equal to 2 upon pi x square upon 2 0 to pi. So it is equal to 2 upon pi pi square by 2 minus 0. So answer will be 5. So this is value of a0. For further calculation, an equal to 1 upon pi minus pi to plus pi mod x cos nx dx. This is definition of Fourier series coefficients. This is equal to 2 upon pi 0 to pi x cos nx. This is equal to 2 upon pi. Now we are going to use integration by parts formula, and the formula is integration u integration v minus integration differentiation of u integration of v and integration of the whole. You may write that dx is up to you, but in abbreviation we can write like this. Here u equal to x and v is cos nx, and therefore this is equal to x sin nx upon n 0 to pi minus integration 0 to pi sin nx upon n dx. How it is? U as it is, integration of cos is sin nx upon n minus differentiation of x with respect to x will be 1, and that of cos is sin nx upon n. Now if we put pi, sin n pi is 0 and sin 0 is 0, and though the value of this first bracket will not be in any calculation for future calculation. So this is equal to 2 upon pi minus 1 upon n cos nx upon n 0 to pi. See here, this is 1 upon n there. Actually there is a sign of minus. But whenever we integrate sin nx, the integration of sin nx is minus cos nx and we should divide it by n. And therefore it is cos nx upon n. Therefore, though this is cos nx upon n square actually. If you write in the brief, it is cos nx upon n square. As integration of sine is minus cos nx and therefore this minus sign is there are two times we have minus sign and therefore it is positive. So this is equal to 2 upon pi n square cos nx 0 to pi, and therefore this is equal to 2 upon pi cos n pi minus 1, and therefore we have values if we put n equal to 1. You know that cos n pi this is minus 1 raised to n. If we put n equal to 1, this is value of n. Is 2 upon pi n square minus 1 raised to n minus 1. So it is 2 upon n square pi. Value of a1 is 1 square, so it is not in calculation. This is minus 1, so it is minus 4 upon 5. Value of a2 is 0 because it is 1 minus 1. Value of a3 is 2 upon 3 square pi into minus 2, so it is minus 4 upon 3 square pi. Value of a4 is 0 because minus 1 is to 4 and therefore it is equal to 1. Value of a5, that is 2 upon 5 square into minus 2, so minus 4 upon 5 into 5 square, and so many other values. Now if we put all these values in the Fourier expansion, fx equal to 1 by 2 a0 plus sigma an cos nx, n is running from 1 to infinity, and therefore this is equal to fx is mod x and this is approximate value. So we may write like approximate values. Therefore this is equal to pi by 2 because the value of a0 is pi. Value of a0 is pi and therefore it is pi by 2 plus value of a1 is minus 4 upon pi cos x plus 0 minus 4 upon pi 3 square cos 3x plus 0 minus 4 upon pi 5 square cos 5x plus other values. So this is equal to mod x equal to pi by 2 minus 4 upon pi cos x upon 1 square cos 3x upon 3 square cos 5x upon 5 square and other values. So this is Fourier series expansion of fx equal to mod x. Now if we put x equal to 0, then what we have? 0 equal to, I say this is equation number 1, and therefore 0 equal to pi by 2 minus 4 upon pi, 1 upon 1 square plus 1 upon 3 square, 1 upon 5 square and other values, and therefore pi square by 8 equal to 1 upon 1 square, 1 upon 3 square, 1 upon 5 square and other values. So this is the way how we find the values by using Fourier expansion. With this sum of fx equal to mod x is over, but still we are going further in the same. Just read it and pause this video for a few moments and check it once more. Dear friends, I want to explain you something more of the previous sum, that is sum number 8. In that one, we have found value of x square is pi square by 3 plus 4 minus cos x, 1 by 4 cos 2x, minus 1 by 9 cos 3x and this terms. Now in this one, if I put x equal to pi, then what it will be? If x is pi, then this is pi square equal to pi square by 3 minus 4, 1 plus 1 by 4, 1 by 9, 1 by 16 and other terms. So we have 2 by 3 pi square pi square is equal to 4 times 1 plus 1 upon 2 square, 1 upon 3 square, 1 upon 4 square, 1 upon 5 square and other terms. Now if we divide this by 4, it will become pi square by 6, and due to that this is value of pi square by 6. Now if we put, I said this is equation number S3. In S3, if we put x equal to 0, then pi square by 3 plus 4 minus 1 plus 1 upon 2 square minus 1 upon 3 square, 1 upon 4 square, 1 upon 5 square and other terms equal to 0. So we have pi square by 12 equal to 1 minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square, 1 upon 5 square and other terms. So this is value of pi square by 12. Now if we add pi square by 6 and pi square by 8, pi square by 12, if we add both of them for simplicity, then I say that this is 2 pi square by 12. Yes, it is. And if I add both of them, what I will have? What I will have? So it is 3 pi square by 12. Is it? Means it is pi square by 4. 1 plus 1, it is 2. Then this term will be cancelled. Plus 2 upon 3 square. This will be double. This will be cancelled. This will be double. And other terms. So if we take 2 in common, this is value of pi square by 8. This is value of pi square by 8, which we find in the example 9, just I have taken before this calculation, and where we find the value of pi square by 8, same as before. Clear? Example 10. Fx equal to x sin x. This is given function. Actually, fx equal to x and fx equal to sin x. I say gx. Both of they are individually odd functions. But whenever we multiply both of them, it becomes even function. This is even function. And therefore, we start the calculation of this sum with a0. X sin x dx. So this is equal to 2 upon pi, 0 to pi, x sin x dx. Now apply this in the formula for integration by parts. We have u equal to x, v equal to sin x. So u as it is, integration of sine is minus cos, and this sign of minus, actually there is a minus sign, but when we integrate sine it is minus cos, and though this is plus, differentiation of x equal to 1, and therefore it is 1 there, and therefore it is not visible there. Whether you write it or not, you have the same value. Whenever I write pi there, it is pi cos pi, means it is minus minus 2 times, so this value is only 5, and whenever we write 0, it is 0. And here integration is sine, and therefore at pi 0, at cos 0, and therefore this is 2 upon pi into pi, and therefore this will equal to 2. Integration of this is sin x, and at 0 it is 0, at pi it is 0, therefore it will not be in calculation. Clear? Also, an equal to 1 upon pi minus pi to pi x cos nx dx. For n equal to all n. Therefore, this is equal to 2 upon pi 0 to pi x sin x cos nx dx. Now here integration of, I say this is equation number 1, and integration of x sin x cos nx dx, and the limit is 0 to pi. Here we are going to apply one more formula.